Yes, hello everyone. My name is Marvin Sendikaddiwa, and this is my ParaView project presentation. So I'm going to be walking you through the different analytics and visualizations that we can obtain from the two data sets, that is CAN and disk. So ParaView, it's a 3D software, and let me go ahead and open. Let me start with the CAN example. So it's located in where the ParaView is installed in examples. Let me open the disk. Sorry, let me start with the disk. So this is how the disk looks like. So we can see that this is sort of a cylinder, but this cylinder has different aspects that are associated with it. And these are some of the aspects. So let me remove some of the minor aspects, and I'm going to remain with pressure, temperature, and velocity. So after applying these properties, they automatically apply to this data set, but removing these properties alone do not affect the visualization of this. So let me go ahead and I'll walk you through the different analytics that we can do on this item. So let me first change the view of this object. So we can see it's a solid object that is kind of grayish. It has a consistent color on the surface. So we can choose how the color, what metric we want to affect the color. So we can view it in terms of pressure. We can see how the pressure affects this object. We can view it in terms of temperature. But now by temperature, inside you will see that it's red. So then we can also view it in terms of the velocity. So the velocity might not make a lot of sense here, but we can add the different filters such as the glyph filter, and to see where the velocity actually flows from. So okay, so let me start by applying a filter called let me apply a filter called apologies. This can only be applied on sorry, it can only be applied on okay, sorry. So let's take it back to the temperature, and we're going to analyze how the different filters affect temperature. So I wanted to clip this item because we are interested in the temperature. So you can see inside it's red, meaning it's probably that's where the highest temperature is. And for my presentation, I'm going to focus it on finding the different thresholds of the temperature. That is the highest temperature and the lowest temperature. So let's go ahead and clip this cylinder to get the internal view. So we do that by right clicking on the object, then we click add filter, can choose alphabetical, and there is clip. So this is the clip. Okay, so we can see we can already choose how we want the clip to impact this item. So we can see that we have clipped our item in half. So now let's go ahead and apply other filters. So now we come to this clip filter. So let's choose a different filter. For example, let's add a filter for threshold, for example. So now nothing has changed. Only a few things have changed on this. So let me first go back to but no, let's analyze the object as is right now. So we can choose the different different thresholds. So you can view it in terms of pressure, but we can see that originally our item, or how this data is visualized, is in terms of the pressure. So sorry, it's in terms of the temperature. So we can pick the temperature, Now the item might disappear, but we can first set the upper temperature. Okay, and then now what we can do, for example, to identify the point that has the lowest temperature, so we can move the upper threshold slowly by slowly. As you can see, the internal contents, they go on disappearing, so meaning they have the highest temperature, and we can reach a point where we are left with only the coldest surfaces of the object. So we can still do it the other way around, where we go on increasing the lower temperature, and we can see that the item is being clipped to remain with the parts that have the highest temperature. So what I'm doing is I'm increasing the lower temperature threshold, and any item that does not fall within this range, it goes on disappearing. So as you can see, so the center has the highest temperature, as you can see. Okay, so that is it for my disk presentation. So let's go on to an animated presentation. So for that, let me open in examples. So let me open can.exe. Oh, apologies, I don't intend to import it here. So we can first remove all this. Okay, then we go ahead and import the can. Okay, so this is how the can looks like. Okay, and what this is, it's really an animation, and we can start this animation by playing it here. So we can see that this is a plastic, this is a brick or something heavy that is falling on the thin of a thin of plastic, and there are a lot of factors that we can pick out from this interaction, so such as a plastic strain. So whenever a plastic is creased, it's strained at some particular point. So as we play this animation, but now to have a better visualization of that, we can change the view. So let's change the color. So let's move it to the equivalent of plastic strain. So as we can see, it has a uniform color at the start, but as we play this animation, we can see that the color has changed. Now they are not changing how we would expect them. So let's add a few more modifications, and that is so we can scale the data. Okay, so we can scale the data. So let's now retry this animation. Oh, apologies. So I want to get a better view. Okay, so this is now much better. So now let's play this animation again. So we can see that when the plastic is strained, it changes color from blue to white, which is what now we would expect in a real life situation. So let's apply a few other filters. So for the next filters, I would want to add a temporal filter. So let me do that. So we can click on this item, add filter, then let's see, alphabetical. No, it's under temporal. So let's add the temporal filter called time. Sorry. Let's see, annotate, temporal, cache, shift, scale, progress bar. No, snap to time step. Let's first analyze this. So now we'd want to compare this side by side. So let's have a split view. So let's render a view. And for this, we want this view to be visible. So as you can see, these are now similar items. But now let's first link the cameras. So we can link camera. Okay, so that they are the same. So we want to get a similar view. So, okay, now when you play this animation, Oh, it's a bit fast, apologies. So let's fix that. So we can change this to snap to time step. Okay, so let's move it to real time. Okay, and we want it to last for 10 seconds. So let's play now this animation. Okay, so maybe this is not the best filter, so let's remove it. We can delete this filter. Okay, so now let's see. Okay, animation is back to normal. So let's add a different temporal filter. So these temporal filters, they are filters that majorly deal with time. So let's add maybe temporal interpolator. And we want maybe the original count to be visible this side. Sorry. Then on this side, we want only the temporal filter to be visible. Now the cameras are already linked. So let's start this animation. Okay, that's much better. That's much better. So now we can go ahead and change the view of this second item. So we can add an extra filter, but before that, let's change its view. Then now we add a filter next to it. So let's add a filter. No, actually, let's first change the view. So let's change to see in terms of let's see points. Let's see how it will work out. Okay, so let's see how wireframe will look like. Then let's choose. Okay, so I'm trying to look for the a better view. Okay, so I think this is a bit much better. This is a bit much better. Okay, so yes, so this is much better. So we can go ahead and add different filters on a different view as we compare it with the original item. So for example, let's take this back to solid, to a surface, and we can add a filter. Okay, let's see. We can clip the item, we can add glyphs, we can do a steam tracer. Okay, clip. Let's see. Okay, clip. What clip does, as we saw it in the previous video, is it splits the item into half. So this is the 3D object, the original one, and now it has been split into half. So then we can get to see the interaction of the different, of the different sections that are usually within the object itself. So that is it about animation. Unfortunately, I want to keep this video short, so thank you for listening.